Ooh-wee. You're going to see a lot of these in the next coming weeks inside of your discrete math class, and trust me, I'm literally doing it right now. These are called quantifiers, and quantifiers talk about the entire domain. So I'll show you examples of what that looks like, but you first need to understand the difference between these two quantifiers. And of course, as I said, I'll show you examples, okay? Just know that each of them stand for different things, okay? This upside down triangle with the little line in the middle of it, actually upside down A, that's probably a better description, stands for all options. You can kind of think of it as everything within the domain, all right? Keep that in mind. Keep that in mind. And this right here, a backwards E, backwards capital E, stands for at least one or there exists, all right? So think of it like that, and I'll show you some of the examples of how to actually apply these quantifiers and what they actually mean for discrete math statements. Let's take a look at this first example right here. So remember what I said about this symbol. This symbol stands for everything in your set, everything in your domain for X, all right? So I'll turn this into sentence form, and maybe it'll be easier for you to interpret. Write equal sign. Let's actually write down an arrow. So this stands for all, so we can write down for all, and then X is next to the for all symbol, so we write down for all X, X is greater than 0. Here's the thing about this. This will depend on the domain. And what I mean by that is the result, the true or false result of this statement will depend on the domain. So quantified statements can be true or false, just like what you've been learning the entire time in your discrete math class. So this guy right here can be true or false, right? But here's the thing about the statement. It depends on the domain of X. Let's go ahead and show you an example. All right, let's go ahead and use the example all real values for X. So all real values for X includes negative numbers, includes pi, includes fractions, okay? But here's the issue with this. This statement, this quantifier, states that for all X, X is greater than 0. But if the domain of X is all real numbers, that means that's not the case, right? That's for all X, X is not greater than 0. The domain includes negative numbers, therefore X is not greater than 0 within this domain. Okay, so if there's a single instance, I mean a single instance of your domain giving you a value of false for this quantifier, then the entire statement is false. And what I mean by this is, I'll show you. Even more examples. Let's go right down T or F again. And let's move these down. Let's go ahead and say X. Let's say the domain for X is all non-negative integers. You guys take a guess, all right? For all X in this domain, all non-negative integers, is X greater than 0? Oh, here's the thing. There's a single value. There's a single non-negative integer that makes this statement false, right? And that's 0. 0 is a non-negative integer. And of course, I didn't expect you guys to know that. You know, before I took discrete math, I didn't even know if I didn't know what non-negative meant. I didn't care about these terminologies. So I didn't expect you guys to know that. If you did, congratulations. But 0 is a non-negative integer. And here's the thing. 0 is not greater than 0. Remember, this statement isn't greater than or equal to. It's just greater than. And the integer 0 is not greater than 0. So here's the thing. That's the only number. That's the only integer that is non-negative that is not greater than 0. It's the only number that proves this statement false. Therefore, due to this quantifier, this guy has to be false. All right. So if I were to write this out fully, you know, I'm just using an arrow right now. But if I were to write this out fully, it would look like this. And it would just equal to false. Or 3 equal signs, whatever your class uses. All right, so just be an equal sign. Right now I'm using arrows because I have multiple different examples of domains. And let's try it one more time. Let's try the domain of where X is greater than You know, I'll put this in like interval notation to be more specific. From 3 to infinity. All right. So 3 included due to this closed bracket, and all the way up to infinity. That's our domain. All right. So from 3 to infinity for x. Are all values of this domain greater than 0, right? For all x, x is greater than 0. Is x greater than 0? Yeah, it is, right? 3 to infinity is, that's definitely greater than 0. If you don't know that, I'm sorry, you should probably go back to kindergarten. But 3 to infinity is greater than 0. For everything, for the entire domain. Therefore, this statement is true. For all x with this domain, there's not a single thing that disproves this statement in this domain. Therefore, this quantified statement is false with this specific domain. Let's take a look at this statement right here. Remember what this symbol stands for? It stands for all. So we write this in sentence form. It might help you interpret this guy a little better. But basically, for all, and then the variable next to it, x minus 1 is greater than 0. Now let's take a look at this statement, and let's go ahead and spit some facts with the domain. And copy and paste this. I forgot that I could do that, so I didn't do it, and then there it is. I rewrote everything last question. But all right, let's take a look at the first example of the domain. Let's say the domain is all positive ints. All right, so all positive integers. Is this true for all positive integers? You guys, and that was not a hypothetical question, a rhetorical question. Sorry. You guys, please answer it. Now that you said the hopefully right answer, and if you didn't, good learning opportunity. But this is true. Okay, and the reason why this is true is because there's not a single number that disproves this. All right. So let's take a look at all the positive integers. All the positive integers are simply from negative, not negative. What am I saying? 1 to infinity. All right. And if I were to write this in interval notation, it looked like this, including 1 to infinity. And keep in mind, the previous one I said non-negative integers. 0 is non-negative, therefore it counts, right? But 0 is not positive. 0 is not positive, all right? So for all positive integers does not include 0. So due to that fact, we're looking from 1 to infinity. So let's test out 1, all right? 1 minus 1 is equal to 0. And 0 is greater than or equal to 0. Therefore, this statement is still true. And if you just keep increasing the value of x, like 2, 3, 4, it's still going to be greater than 0, right? No matter how high you go up with the integers, it's not going to go negative. All right. So here's the thing about this. There's not a single value in this domain that makes this statement false. There's not a single value. Therefore, it is true. So for all x in the domain, all positive integers, x minus 1 is greater than or equal to 0 is true. Okay, as long as the domain is all positive integers. All right, how about let's try all real numbers, and hopefully you guys can already tell. It's kind of throwing it out there. Hopefully you guys can already tell this, but yes, this is false. That's because a negative number, like I don't know, -1 minus 1, right, equal to -2. -2 is clearly not greater than 0. And -1 is included in real numbers, therefore this is false, right? So for this for all thing, there needs to be a single example that proves this statement false for it to be entire thing to be false. Okay? So only for this quantifier here, there needs to be a single case, one single case of this guy being false, entire thing is false, right? Because the statement is for all. It's for all. Therefore, it has to apply for every single value in the domain. But there's a single value that denies this domain. All right, well, the entire thing is false. Kick it out, your house, kick it out, your tissue box. I don't even know why I said that. I was just looking at my tissue box next to my desk right now. I have allergies, so maybe I'm sounding a little snotty right now. All right, last domain. Let's go ahead and try all non-negative integers. All right, you guys test it out. Okay, now that you test it out, it is drum roll. It is false. Remember, I already foreshadowed this at the beginning of the problem, but remember, non-negative integers include 0, and 0 minus 1 is -1. Oh, I wrote the 1 kind of nice there. All right, but -1 is not. It is not greater than 0. All right, this guy is not greater than 0. Boom. There's a single case of being false. Remember, any other non-negative integer other than 0, this guy is true, right? 1, 2, 3, 4, this guy will be true. But there's a single instance, just one guy in the domain that makes this false, and the entire thing is blown to shreds. So yes, this guy is false because there's one value in this domain that makes this statement, I guess, this statement false. So this guy is the next quantifier I was talking about. So the previous one, if a single value in the domain was false, then this guy is, then it was false, right? The entire thing was false. But this one's the opposite. If a single value is true, then the entire thing is true. Okay? Yep, keep that in mind. So the previous one guy false, the entire thing false. This guy, one guy true, the entire guy true. And I'll show you how to word that in a sentence. Let's go ahead and write down the true or false statements first. Now, frankly, to be honest, I actually don't even have the domains prepped. I literally come up with them along the way. So hopefully I can think of 3 domains that make this tricky or a little easy to understand. But basically this sentence is, let's see, this sentence right here is there exists. So the previous one was for all. Now it's there exists, or you can also say there's at least one value, all right? So there exists an x where, and of course you can word this differently. You don't have to word it exactly like I do. There exists an x where x squared is equal to x. So let's take a look at a couple domains right now. Let's take a look at the domain all real numbers. All right, so all real numbers, right, includes negative numbers, rational numbers, irrational numbers, anything of those sorts. Okay, positive numbers, right, 0 includes everything except for imaginary numbers. Complex numbers are actually very fun. If you're learning quantum mechanics, which hopefully I'm gonna make a quantum mechanics playlist, but if you're learning quantum mechanics, complex numbers, they are a blast. But for all, that's besides the point. For all real numbers, is this quantifier true? Will this quantifier make this statement true, right? Or is this quantified statement true, right? There exists an x where x squared is equal to x. Well, I can already think of 2. When x is equal to 0 and when x is equal to 1, right? 0 squared is 0 and 0 is equal to 0. And 1 squared is just 1 and that's equal to 1. Okay, so this guy right here, remember, if there's even one instance of the domain making the statement true, if there's one instance of the domain making this equality predicate, whatever you put in here, true, then the entire thing is true, right? So I already thought of like 2 examples, 0 and 1. Therefore, this quantified statement is true with the domain of all real numbers. Let's go ahead and use all positive ints. All right, you guys try this out yourself. So all positive integers is from 1 to infinity. Does not include 0 because 0 is not positive. So 1 to infinity. And 1 to infinity, well, includes 1, right? So here's the thing. 1 is a value that would make the statement true, right? X squared is equal to x. 1 squared is equal to 1. Is this true, right? Yes, it is true. 1 squared is still 1. So even though there's only a single value in this domain, all positive integers, right? 2, 3, 4, anything else wouldn't make this true, all right? There's only a single value in this domain that makes it true. It is still true. So for the quantifier, little backwards e, right? It is true with the domain of all positive integers. Okay, let's go ahead and look at the last domain. Let's choose all negative integers. All right, let's take a look at all negative integers. And remember, 0 is not negative or positive, so 0 is not included. So try this out. Well, let's take a look at this. All right, the first number, the smallest number that I can possibly think of right now is negative 1, or the smallest magnitude number, I guess. The one that's closest to positive is negative 1, right? So let's test out negative 1. Negative 1 squared. Remember, make sure to put the parentheses around it. Negative 1 squared is equal to negative 1. Is this true? Well, negative 1 squared is just positive 1, right? If you square any negative number, it turns positive. So is 1 equal to negative 1? Well, you would be fibbing if you thought that was, if you stated that and you thought it was true. Or if you knew it was true and you stated that, you'd be fibbing. It is not true, okay? So negative 1, oh my god, negative 1, it will never give you a true value for this statement, right? How about negative 2? Well, negative 2 squared is equal to negative 2. Is this true? Remember, if you square any negative number, you get a positive number. And here's the thing, a positive number will never equal a negative number. So no matter what you do, on this side, you are squaring negative numbers in our domain, right? And this side, you're squaring negative numbers, and you're expecting it to equal a negative number? That makes no sense, right? No matter what negative number you put in here, this statement will not be true. So there's not even one instance of this guy being true. There's not one instance in the domain of this guy being true. The entire thing is false. That's the only time when the entire guy is false. So the previous one, everything needed to be true, right? And let's show you the symbol for you visual learners. So this previous one, everything needed to be true in order for the statement to be true, right? And now this guy, everything needs to be false in order for the statement to be false. Okay, let that soak in. Let that soak in. Now that you're at the end of the video, I would just like to say thank you to you guys. I don't know, this is gonna make my video longer, probably lower the click-through rate, but it's whatever. I like doing this. It's very fun. Making YouTube videos is very fun. Teaching you guys, making classes very easy. Hopefully, I'm making these things easy to understand. But if I'm not, I'd be happy for critique. Tell me if a part is confusing. Of course, I will. Future videos, I'll make it better. But oh my God, I hit my first video hit 1K views. That's my first video, and if you're curious, it's called the trig integrals video. Oh my God, I hit it this morning. I woke up and I looked and I was like, holy shit, it's 1K. I already saw it coming like a long way because it just kept growing and growing and growing. It just kept getting more and more views. And I was like, holy shit, this might be my first 1K view video. I'm actually pretty excited. I'm pretty happy. Thank you guys. You guys are amazing. I don't know. I'm actually really grateful for 1K views. I never thought that 1K people would watch me, listen to me speak, listen to me talk about math. You know, a big goal of mine in the future is hopefully, I would love to talk about math, physics. I don't even know any topic. I just love public speaking. The adrenaline rush is just so surging. I actually asked my professor recently if I could, one of my old professors, right, if I could lecture the class for him. He said no, right? But I'm going to ask my professors, the rest of my professors this semester, if I could do that. And hopefully that's a good idea for you guys. If you're willing enough, if you're brave enough, literally ask the professors if you can lecture the class. And if you want to compromise, ask them, just do a single question. Just do a single question, right? I don't know, present a single practice problem. I just like public speaking, you know, being able to say whatever you want in front of a bunch of people. Hopefully I reach out to millions. That'd be the goal at the end, but I don't know. That's just 1 in billions. Hopefully I could, you know, I'd be very happy. But let's continue on with this problem. That's enough rambling. I imagine a lot of you skipped the parts where I talked. I'll put timestamps so that you guys can skip if you want. But look at this guy, and I'll reword this differently. Previous one, I said there exists. This one, it is. Let's reword this differently for some exposure. You know, let's say at least one value of x, at least one value of x holds x squared is greater than 0. And holds, I don't know, I guess I ran out of space. I guess holds true for x squared is greater than 0. So just imagine holds true here. Actually, I could put holds true. Let's make this consistent. Let's make my teaching not lazy. Holds true for x squared is greater than 0. So sometimes you're going to see at least one value, or at least one, if you see at least, it usually means this quantifier right here. So let's go ahead and do that. Right here, we actually write down true and false. True or false. And copy and paste everything here. Copy, paste, paste again. And let's take a look at a couple different domains. Let's take a look at the domain of all real numbers first. I like to start off with that one. So all real numbers. Is this true? Well, I can already think of a singular example. So remember, for this statement, if one guy's true, the entire thing is true, right? So think of one. X equals 1, right? X equals 1 is a rational, not a rational, what am I saying? A real number, and 1 squared is greater than 0. So for this case, booyah, this entire guy is true because a single value in the domain is true. Let's go ahead and try out, all non-negative ints. Right? And here's the thing about non-negative ints. That includes 0. So, also, it went silent there so that you guys could do it in your head. But, remember, x equals 0. This is false. Right? X squared is not greater than 0. It is equal to 0, but it's not greater than. Here's the thing. This guy, this quantifier, only needs one value to be true, right? So you could just think of one value in this domain to make it true. X equals 1 is another one, right? That's a non-negative integer. X equals 3, right? So just because there's one value that makes this guy false doesn't mean the entire thing is false. For the previous quantifier, that would be the case. A single false value, the entire thing is false. I know I repeated that a lot in the video, but when you're first learning things, I find it helpful when I'm learning for someone to repeat things often. Might be annoying, but you can't just take in everything at the same time. It's very hard to learn everything all at once and then remember the vocab words that I taught you 30 minutes ago in the lecture. But this in the case, right? I just need one value of this guy to be true for this quantifier specifically for the entire thing to be true, right? So an example of non-negative integer, as I said, x equals 1. That makes this guy true. 1 squared is greater than 0. So this entire thing is true, right? I just thought of one singular example for that. Let's try the last domain. And I'm very uncreative, so I'm just going to make the domain just a single value, 0. I'll just make this domain a single value, 0. Test this out, okay? Is this true or false? Well, the domain is just a single number, so you can just test it. But it's false, right? Since the domain is just a single number, there is not one value that is true, right? Because there's only one value, right? So if we test this out, 0 squared is just equal to 0. And is 0 greater than 0? It's not. It's just equal to 0, but it's not greater than. So this guy, this domain right here, doesn't really have any. It doesn't have any values that make this statement true. Make this x squared is greater than 0 true. Therefore, the entire thing is false. So remember, everything needs to be false in the domain for this guy to be false. For this quantifier to be false. Everything needs to be false for this guy to be false. Okay. And it's the opposite for the other one, for the other quantifier. Actually, maybe I should look at the. There's probably some name for the letter, but. A little warning, it is not that simple because you can have statements with multiple quantifiers. Bum 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 bum. I don't even know what I'm doing. You can have multiple quantifiers, okay? The statement can look like this with multiple variables. And here's the thing about this. You have to interpret these guys differently depending on the order you wrote the quantifier. Yikes. And I'll talk about that in the next video. But that was just a warning for you guys because it's not this simple. This is just this introduction. But hopefully, this video helped. If you found this helpful, consider subscribing and liking the video. And I love all of you guys. You're amazing. 1K views. I'm so happy. Thank you.